Welcome to Brain Vision.
Hi, in the given problem, the area of the floor of a rustic cabin has been given as 3.5 meter to 3.0 meter. Means its length is 3.50 meter and its breadth is 3.0 meter. The height of this room, of this cabin, has been given as 2.5 meter. So we can say the area of its walls, excluding the floor and the ceiling, will be given by twice of h into L plus B. So putting these known values, this is 2 times of 2.5 meter multiplied by 3.50 plus 3.0 meter. So overall, this area of the walls of the cabin comes out to be 32.5 meter square. Now, it is given that the outside temperature is 2 degrees Celsius and inside temperature is to be maintained at 19 degrees Celsius. So the difference of temperature will be T2 minus T1, means this is 17 degrees Celsius. The width of the wood walls of the cabin, this can be represented as dxw, and that is given as 1.80 centimeter, means 1.80 into 10 raised power minus 2 meter, and the width of the insulator is given as, we can say it dxm, the insulating material, and that is given as 1.50 meter or 1.50 into 10 raised power minus 2. This is 1.50 centimeter or 1.50 into 10 raised power minus 2 meter. Now, the rate of the heat at which we have to operate the heater is given as dq by dt is equal to 1.25 kilowatt, or it can also be written as 1.25 into 1000 watt. So this is 1250 watt. Now we know the rate of heat transfer through the walls is given by an expression dq by dt is equal to k, where k is the thermal conductivity of the layer of the material through which the heat is flowing, multiplied by a, where this a is the area of the layer, and then this is dt by dx. The temperature gradient means the difference in temperature divided by the width of the layer. So putting all these values, known values here, we get to know the expression for k will become k is equal to dq by dt divided by a dt by dx, or we can say this is 1250 watt, 32.5 meter square for area, 17 degrees Celsius for the change in temperature, and overall dx means if we add these two widths, this width, overall width will come out to be 1.8 plus 1.5 means 3.30 into 10 raised power minus 2 meter. So here it is 3.3 into 10 raised power minus 2 meter. So finally, this thermal conductivity of the combined layer of wood with the insulating material comes out to be 0.075 watt per meter per Kelvin or per degree Celsius. So now in series combination, the overall thermal conductivity is given as dxw plus dxm divided by dxw divided by its thermal conductivity, means the thermal conductivity of wood, plus dxm divided by km, means the thermal conductivity of insulating material, which is missing. Actually, we have to find it. So plugging in all known values, for K this is 0.075 is equal to, for the total width of the combined layer, this is 3.3 into 10 raised power minus 2 divided by, for dxw means width of the wood wall, this is 1.8 into 10 raised power minus 2 divided by thermal conductivity of wood, which is given as 0.06 plus 1.5 into 10 raised power minus 2 width of the insulating material divided by km, which is finally missing. So here it comes out to be, if we solve this 1.8 into 10 to the power minus 2 divided by 0.06, it comes out to be 0.3. So this is 0.3 plus 1.5 into 10 to the power minus 2 divided by km, which is missing, will be equal to 3.3 into 10 to the power minus 2 divided by 0.075. On making a cross multiplication, actually we have shifted this denominator this side, and this 0.075 has been shifted to the denominator of 3.3 into 10 to the power minus 2. So finally here it becomes 0.44. So this 1.5 into 10 to the power minus 2 divided by km comes out to be 0.44 minus 0.3 means 0.14. So km will get a form of 1.5 into 10 to the power minus 2 divided by 0.14 watt per meter per Kelvin. So finally, the value of thermal conductivity of the insulating material comes out to be 0.107 watt per meter per Kelvin. And this is the answer for the given problem. Thank you.